Hey guys, happy Thanksgiving. This is the first of 3 15-minute videos, and I'm just going to work my way through some of this Chapter 5 probability section. Okay, so it is good to kind of read through this. It gives an overview of the whole chapter. Notice we have kind of gone through each section a little bit. We'll do a couple more activities in this last section about conditional probabilities and independence, right? And section 5.1 we did when we talked about how many free throws Miss Kruzmark can take and the soda contest. Okay, so notice how the main ideas in this section was this idea of long run relative frequency and how that probability is not predictable in the short run, but predictable in the long run. So this first concept, you don't have to write this down, but this was the notes that we took after the free throw. So these main ideas are literally say exactly the same thing. So our notes mimic what this workbook does. And so again, this is a way of seeing it in a different way. So as we said, the long run relative frequency is always between 0 and 1. In the short run, it's very unpredictable. But in the long run, it kind of settles down and approaches what we would predict to happen. So we use words like, if something is set to happen, like for instance, flipping a coin and getting heads, if we do the flipping of a coin many, many times, the proportion of heads that we get would approach its probability of 0.5. But in the short run, we might not get that. So if we did this, I got heads all at once. So that's an experimental probability of 3/3, right? Which is 1. But in the long run, if we kept going, we might get a tail, a head, a tail, a head, a tail, a tail, right? As we keep going, eventually, in the long run, we should get, or it'll settle down around 50% of the time I'll get heads about, right? So using that information, I hope you took an opportunity to kind of use this as an extra practice. So check our understanding. I can interpret the probability of a long run frequency. So here's another scenario. What's the probability of drawing a jack, a queen, or a king from a standard deck of playing cards that's approximately, they're telling us it's approximately 0.23. All right, so the notation we've been learning, you would maybe write it like this, right? And this is what we covered in the free throw activity. So we can say, explain what the probability they've given us means in the context of drawing cards. So what this is saying is, if we draw from a deck of cards, because that's the act we're doing, right? And then back to our script, right? Back to our notes. If we draw many, many times, right? Many, many times, about 23% of the time, we'll get a jack, queen, or king, right? And this word's very important because we know that this is chance behavior. So the next question asks, does this mean that if we repeatedly drew cards, replaced it, shuffled it, drew again 100 times in a row, will we draw a jack, queen, or king 23 times? Why or why not? Well, we're essentially saying here no, because drawing a card is this act is chance behavior. We should expect to draw a jack, queen, or king about 23% of the time, but not exactly. Okay, now let's take a look at the next example. So the second concept we did and the second activity was the soda contest activity, right? So we see in the words here that we can use a simulation of chance behavior to simulate what chance behavior would look like. So what were our notes from the soda contest? Here they are, and I just kind of copied and pasted them here. You don't have to write them again. You've got them in your notes. But I find it's important that you're probably referring to this, right? So in this example, it says a popular airline knows that in general, 95% of the individuals who purchase a ticket for a 10-seat commuter flight, so it's just a little small airplane, maybe going between Boston and New York, that only 95% of individuals actually show up for the flight, meaning 5% don't show for one reason or another. In an effort to ensure a full flight, the airline sells 12 tickets for each flight, so they oversell the flight. Let's design and carry out a simulation to estimate the probability that the flight will be overbooked, meaning more people show up than there are seats on the plane. Okay, so looking back in our notes from the soda contest activity, we are pretty much just swapping out what we wrote there. Use a random number generator to get 10 integers between 00 and 99. Okay, we want to make 5 in the numbers, so it doesn't matter which 5. I just set these 00, 01, 02, 03, 04, those 5 numbers to represent didn't show up, because if 95% show up, that means 5% don't show up. Then I let the remaining numbers, 05 to 99, be representative of showed up for the flight. I'll need to ignore repeats and then I need to count how many of the 10 unique integers were between 05 and 99. Hold on, let me think about this here. Wait, they sell 12 tickets. Okay, I gotta go back here. I need to change this to 12, yes, because I sold 12 tickets. Yeah, let me get this straight. Okay. So yeah, I'm going to use a random number generator because I'm going to sell 12 tickets. So each of those are going to represent me selling a ticket. I'm going to count how many of the 12 unique integers were between 05 and 99, because that's going to be representative of if they showed up or not. I'm also going to need to do this many times and then estimate the probability that the flight was overbooked. Okay, now we did this together where each person kind of generated a random number, but I'm sitting here by myself, right? So how can I generate a bunch of numbers all by myself? I'm just going to use some of the same things we did before. So if you go to random.org, right, notice there's a tab here at the top, numbers, and I'm going to go to set of integers. So I wanted to generate 12. Oh, it doesn't matter how many. I'll just say 10 sets. 10 sets with, I want 12 unique numbers, like, right? So that word's important. And then each integer should have a value between 1 and 100. So this is actually slightly different than what I've described there, but both would be appropriate. Okay. So I'm going to hit enter, and it will... Okay, get set. Boom. Okay. So in this first set of 12, it looks like 10. Yeah, they showed up. Yeah, so I'm going to need to go back and modify since this random number generator behaved slightly different. Okay, so I have a random number generator that actually lets me generate numbers, unlike a calculator, from 1 to 100. Okay, and so that means I'm going to let the numbers 1 through 5 mean don't show up. And then that means 6 through 100 is showed up for the flight. Okay, so back to our random number generator. Okay, so, oops. I'm going to take a picture of this. Take this back to my, throw this up here on my board here. So, okay, let's think this through. notice all 12 people showed up because none of the numbers between 1 and 5. All 12 showed up. All 12 showed up. Oh, you had one no-show, right? All 12 showed up. All 12 showed up. Here you had one no-show because that was the number 5. Ooh, this one I had 2 no-shows. Okay. So it says carry out a simulation to estimate the probability. Now I can do this a number of ways, but I just did a set of 10 and a couple different ways I could do this. But what did I get? Out of a set of 10, a 1 show and a 2. Okay. So now I'm going to go to Staplet, and it's how many people showed up for the flight. So I actually had 12, 12, 12, 12, 12, 12, 12 out of a set of 10, right? And then I had 1 that 2 didn't show up, 1 that 11 people showed up. Okay, two, excuse me, that 11 people showed up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 1 extra 12. Okay, so that's my data so far. Notice I could have also just put, I could quantify how many people overbooked. But so that could have been, I just decided to collect data how many people showed up. So all 12 showed up in 7. Now, I feel like I need more data than 10. So I'm going to do this again. Do it again, please. Okay. So it did it again. I'm going to take a picture because I like to be able to write on my numbers here. So in my next set, right? In my next set, if I go back here, let's see. Count up my no-show. Okay, so here's 2 no-shows. Everybody showed up, everybody showed up, everybody. Ooh, 3 no-shows. Everybody showed up. 1 no-show. 1 no-show. 1 no-show. And everybody showed up. Wow. Okay, so that's a lot of variation in data. So, that's going to be 1, 2, 3, 4, 5 12s. So 1, 2, 3, 4, 5 12s. And then this is 11 people showed up. So 1, 2, 3. 3 had 11 people show up. 11, 11, 11. This one had 10 people show up, and this people had only 9 people. So 10 and 9. Okay, so 10 and 9. All right, so let's begin our analysis. And so we have 10 numbers here, right? Or excuse me, 20. And I'm going to take this data back to my table, okay? And it says, right? The last step is, right, use my results to answer the question. So out of these 20, what was my proportion? So out of 20, how many times did they overbook? Well, this was an overbook and this was an overbook. So it looks like these were the only times I didn't overbook. So that gives me 3, so 17, I overbooked. Proportion overbooked. So it looks like overbooking is pretty likely here.